Alright, you're welcome to today's class, and this is going to be a very simple and effective class because what we want to do today is to find the best analysis for this circuit. Alright, and remember this is a DC circuit arranged with different resistors. So how can we find the combined resistance according to the question? Sometimes we call it equivalent resistance, or you call it combined resistance, or sometimes you call it the total resistance. If you're ready, let's get started. Now, what you should always consider is which one is the series and which one is the parallel. Now, if you look at the diagram, you realize that there are two junctions. The junction between the 10 ohm and the 8 ohm is at here, at this point, and there is another junction here. Now, since the two resistors have two different junctions, they can be regarded to be in parallel. So how do I solve it? I'm going to solve these two. I'm going to say resistance in parallel for one is going to be equal to, I will say that 10 times 8, 10 times 8 all over 10 plus 8, which is 10 plus 8. This is how I handle two resistors in parallel. This is what I'm going to do. I'll multiply them, divide them by their sum. So I'm going to have 80 over 18, and the answer is going to be 80 divided 18 is 4.4 ohms. That is the first. Now I am coming into this part. If you get to this part as well, you realize that there is a junction here and there is another junction here. I choose this place to be my own junction. So these two are in series, but they will add and become parallel with this particular 12 ohm resistor. So I'm going to say that resistance in parallel 2 is going to be this plus this is 20. 20 times 12 is 240. So I have 20 times 12 is 240. Therefore, this 20 add to this 12 is going to be 32. So we are going to have that 240 divided 32 is going to be 7.5 ohms. All right. So we have dissolved this to be 1. I've dissolved this to be 1. Then whatever I have here, I'm going to add it to this one. Therefore, 7 ohms plus 6 ohm, they are going to give you 13.5 ohms. Now, I have just two. All of them have been resolved to just two, 13 and 14. Now, the question is, are they in parallel or they are in series? If you look at them, you know that they are in parallel. For them to be in parallel, I'm going to still solve them as parallel resistors. So this and this can be solved in parallel, and I'm going to handle it by saying 4.4 times 13.5 all over 4.4 plus 13.5. Now 4.4 times 13.5 is 59.4 all over. This is going to be 17.9. So I'm having 59.4 divided 17.9. So I'm going to have 3.32 ohm. And this is the total resistance offered by all these resistors, and that is what this voltage is going to supply its energy in order to power. Have a nice time, but please don't forget to hit the subscribe button, like this video, and share it. Also remember that the best thing to do is to ask questions where you found it difficult.